Welcome to all. Today we can discuss two position synthesis of mechanisms, two position synthesis of four-bar mechanism. Here is the detailed procedure. This is the detailed procedure. One by one, step by step procedure is given in this presentation. These are all different steps in two position synthesis of four-bar mechanism. Now, this is the final figure. This is the final figure of the four-bar mechanism drawn with the help of the detailed procedure given in the previous slides. And now we can discuss a particular problem. Here is the problem. Design a four-bar mechanism so that theta 1 2 is equal to 45 degree and phi 1 2 is equal to 55 degree. Both input and output cranks should move in the clockwise direction. This is the question. Here this particular point is the pivot point of the input crank, and this point is the pivot point of the output crank. Then we can say that when this input crank rotates through an angular displacement of theta, then corresponding angular displacement for the output crank is represented by phi. That means if this is the initial position of the four-bar mechanism, and here when we give an angular displacement of theta degree to the input crank angle, then this is the final position of the four-bar chain. Then this output crank, this is the output crank. This output crank rotates through an angular displacement of phi degree. That is the concept of this two position synthesis. This is the first position of the output crank angle. This is the second position of the output crank angle. Similarly, this is the first position of the input crank angle. This is the final position of the input crank angle. If we can represent this point as A and this point is A1, then this angular displacement is represented by theta 1 2. This is the first position and this is the second position of the input crank. Here this is the first position of the output crank, and this is the second position of the output crank. Then this angular displacement is represented by phi 1 2. That is the condition. Here the theta 1 2, here theta 1 2 is given, also phi 1 2 is given. Then we must design a four-bar mechanism which satisfying the given input crank position or input crank condition and the output crank conditions. Okay. Then first step, select points A and B on the frame at a distance of 3 cm. That means AB is equal to 3 cm. We can select this length randomly, because in this particular question that length is not given, so that we can select any length, any convenient length for AB, link AB. These are the different steps to design the 4-bar mechanism. And this is the final answer. Here, first step, select points A and B on the frame. Select A and B on the frame at a distance of 3 centimeter. That means AB is equal to 3 centimeter. Here AB, we can select this, the first link AB. First link length is 3 centimeter, and we can easily draw that link AB. Then in the second step, assume the length of output link BC1 is equal to 3 centimeter. BC2 is located such that the angle C1BC2 is equal to 55 degree. Here output crank angle is equal to 512, that's given as 55 degree. Then first we can draw the initial position of the output crank BC1, then the final position of the second position of the output crank. The length of BC1 and BC2 must be same. We can select that length randomly, because that length also not given in the question. Then this angle C1BC2 must be equal to 55 degree. That must be equal to 55 degree. That 55 degree is equal to 512. Okay. Then the third step, join C1 to C2 by dotted lines. Find B, the perpendicular bisector of C1 C2, to pass through point B and locate any point small letter p on it. Join C1 to P. Then in the next step, connect C1 and C2 by dotted lines. Then draw a perpendicular bisector to C1 BC2. We can draw an arc of radius greater than the half of the length C1 C2, and we can draw an arc like this. Then another arc having center as C1, and we can draw that arc like this. Similarly, at this side also we can draw that arcs, the same arcs having the same radius as in this particular side. Then we can easily draw the perpendicular bisector. This perpendicular bisector which is passing through capital B. Then we can select an arbitrary point. Select any point on this perpendicular bisector and name it as P. Okay, that is the step given, or that is the third step. Then measure angle C1PB, that's equal to beta, that's equal to 13 degree. Measure angle C1PB, that's equal to this angle, and that angle is equal to represented by beta, and that's equal to 13 degree. Okay, next, fifth step, draw line AP, small letter AP, from P passing through A. Draw a line AP passing through capital A. Draw a line small letter AP passing through A. We can draw that line, small letter AP, line AP. Then next, draw line PM such that angle APM, capital A, small letter P, capital M, APM is equal to beta. This angle is equal to beta. Then angle APM is equal to beta, that's equal to 13 degree. Here draw a line MP. Draw a line small letter PM or MP. Draw a line MP which is inclined at an angle beta degree with that straight line, small letter AP. We can draw that line MP. That is the sixth step. That is the sixth step. Then in the next step, from capital A, draw a line AN, capital AN, such that small letter a, capital AN, angle small letter a, capital AN is equal to half of theta 12. Half of theta 12 is equal to 45 degree divided by 2, that's equal to 22.5 degree. Then angle AAN, small letter a, capital AN is equal to 22.5. 22.5. Then we can draw a line capital AN, capital AN, capital AN, such that the angle small letter a, capital AN, this angle must be equal to, theta 12 by 2, this degree, theta 12 by 2 degree, that's equal to 22.5 degree. 22.5 degree. Then we can easily construct that line, capital AN, capital AN. Then in the eighth step, AN intersect PM at point D1. AN intersect MP at D1. We can locate this D1, capital D1 at the intersecting point of M small letter P, line M small letter P and line capital AN, we can locate D1. Then in the ninth step, join A with D1, and C1, join A with D1 and C1 with B. Join A with D1 and C1 with B. This is the required 4-bar mechanism. Join A with D1 and C1 with B. Join A with D1 and D1 C1 with B. That is the required 4-bar mechanism. Here we have already located C1, B, A, and now we can locate this point D1. Then A, D1, C1, B is the required 4-bar mechanism. Then make angle A, capital A, D2 is equal to theta 12 by 2 degree, that's equal to 22.5 degree, and set A, D2 is equal to A, D1. Angle small letter A, capital A, D2. Small letter a, capital A, D2. That angle is equal to, this angle is equal to theta 12 by 2. That's equal to 22.5 degree. Then A, D1. This length must be equal to A, D2. Then we can locate the second position of the input crank. Then A, D2, connect A, D2, C2, B. That is the second position of the given or derived 4-bar mechanism. Second position of the newly created 4-bar mechanism. Join A, D2, C2 and B by dotted lines. And then this is the final answer. Thank you all.